This video will cover finding the discriminant and using the discriminant to determine the number and type of roots of a quadratic function. First, a couple of formulas that we need. We're going to use b squared minus 4ac no matter what scenario. So if b squared minus 4ac is less than 0, the equation has 0 real solutions, but 2 imaginary solutions. The graph does not cross the x-axis. b squared minus 4ac is equal to 0 means that the equation has 1 real solution, and the graph touches the x-axis at 1 point. Our final option here, b squared minus 4ac is greater than 0. The equation has 2 real solutions, and the graph crosses the x-axis at 2 points. First up, y equals 3x squared minus 6x plus 10. We want to remind ourselves that in any quadratic, it goes A, B, C. So using our formula, it's going to be negative 6 squared minus 4 times 3 times 10. This becomes 36 minus 120. 36 minus 120 is negative 84. Negative 84 is less than 0, which means we have 0 real solutions. So 0 real solutions because negative 84 is less than 0. Next example. Y equals 2x squared minus 4x plus 2. Plugging into our formula, again, negative 4 squared minus 4 times 2 times 2. Negative 4 squared is 16. 4 times 2 times 2 is 16. 16 minus 16 is 0. 0 is equal to 0, which means that I have 1 real solution. Next example, y equals x squared minus 7x plus 12. Plugging this one in, we get negative 7 squared minus 4 times 1 times 12. Negative 7 squared is 49. Minus 4 times 1 times 12 is 48. That's equal to 1. 1 is greater than 0. That means that I have 2 real solutions. Those were 3 examples of using the discriminant. Now we're going to take a little bit of a leap back and review how to factor. The first example here, x squared minus 9x plus 18. We need factors of 18 that add to negative 9. The 2 numbers that we're going to use are negative 6 and negative 3. So this will become x minus 6 and x minus 3. Our example in the middle here will take a little bit more work. 3x squared plus 11x plus 10. In this one, remember, we're going to multiply 3 times 10. 3 times 10 is 30. And then factors of 30 that add to 11 are going to be 5 and 6. So we'll plug those in. 3x squared plus 5x plus 6x plus 10. Next we group. My common factor between 3x squared and 5x is just x. That leaves me 3x plus 5. In my second pairing here, my common factor is 2. So I'm going to factor out a 2. That leaves me 3x plus 5. Next, I'm going to write my final answer as the quantity x plus 2 times the quantity 3x plus 5. Finally, we've got an example over here of x squared minus 49. X squared minus 49 is an example of the difference of squares. I know that because there's two terms that are both perfect squares. The answer here is the quantity x minus 7 times the quantity x plus 7. That concludes this video. We've done practice on the discriminant and on factoring.